Welcome everyone. My name is Jagoda Konarska and I'm Marketing Manager at PDM Analysis. Thank you for being here with us today. I'll start with introduction, then I'm going to show you our tools, SCORG and SCORG Alto, which is a cloud-based solution. Later on, I'll mention what else we can offer, about our collaborations, and about our short course, which is right after the conference. Did you know that around 20% of energy generated in developed countries are used for compression? Screw compressors and expanders play a significant role in industrial compression, for example, refrigeration, air conditioning, oil and gas sectors. There are almost 2 million new screw compressors manufactured every year. They consume a vast amount of energy, and even small improvements in their performance will make difference in reducing environmental impact and carbon footprint. Therefore, the improvements are essential to reduce our damage to environment, to make them sustainable and improve our lives. Our tool is unique software that enable that. PDM Analysis develops, markets, and supports SCORG, a unique software for the design and analysis of positive displacement screw compressors, pumps, motors, and more. Who we are? The beginnings of SCORG are dated to 1998, when Professor Kovacevic has started his research about CFD analysis for screw compressors for his PhD. In 2001, they completed the first 3D CFD analysis for oil-injected and oil-free compressor using novel grid generation to be built in SCORG and CFD software Comet of CD Adapco. 16 years ago, SCORG was officially launched at 4th edition of this conference as a part of package DISCO. SCORG was continuously developed and used with different CFD solvers, and in 2011 Dr. Sham Rane started research and development of variable lead, variable profile screw machines. In 2014, PDM Analysis was appointed by City, University of London, to continue developing and commercializing this software. Since then, we established connection with partners and distributors all over the world. And finally, in 2020, cloud-based platform SCORG Alto is launched. It allows the use of our well-known software SCORG remotely on Microsoft Azure cloud machines. I'll hand over to Professor Kovacevic, the director of PDM Analysis, who will talk about features and potential of SCORG.
SCORG is the unique software for design and analysis of positive displacement machines, including screw compressors, expanders, and pumps, internally and externally geared machines, vane compressors, expanders and pumps, roots blowers, gear pumps, and some other machines. And it is used for CFD analysis, thermodynamic analysis, and some other means of analysis of these machines. The structure of SCORG is shown in this slide, and on the left-hand side you can see modules which are basically profile and geometry analysis module, thermodynamic or lower order chamber model, and then a module for 3D CFD analysis of screw machines. The first module is used to import or generate profiles, and importing or profiles could be from a data file or from a CAD system, and then it is used to set up the machine as you want it to be and to calculate chamber volume, areas, and other important elements which are required for second thermodynamic chamber model. Thermodynamic chamber model could be run internally in SCORG or by some other software. In this case, this is a GT Suite, so it could be either internal or external thermodynamic model to calculate gas pressure and temperature, leakages, power flow rates, forces, obviously boundary maps that is later used for CFD analysis and finite element analysis of the machines. And then the latest model which is a CFD module, is for grid generation of meshes for screw machines, and then pre-processing to be used for variety of CFD solvers like Cimerix, ANSYS CFX and Fluent, Star CCM Plus from Siemens, and OpenFOAM.
Now I would like to introduce to you new features that we have in version 5.9. So apart for profile and geometry analysis, we have a few new very exciting things. The first one is the batch command module. It opens basically use of the SCORG with for multiple other applications. For example, optimization of rotor profiles with the external optimizer. It is fully flexible now, and it can be used. Or other, controls and integration of SCORG. So we see that as a major step towards expanding and using SCORG for many other analysis rather than just for analysis of a machine itself. Also, we have started implementing features which are related to CAD, to design, furthermore. So first of them was export. CAD export to STEP, IGES, and STL formats. Based on the setups from SCORG, it is now possible to export CAD geometry, which should be very useful in a design. For thermodynamics, a part of these batch commands, we also have introduced bearing selection module. Based on the forces, you can select the bearings. And we did a lot of bug fixing and improvements in thermodynamic model. GT suite models are updated. Bearing loss calculation module is introduced in there, and there are some examples on using that for optimizing machines and for two-stage compression expansion calculation. And in 3D generation, a part of obviously batch commands which come there are export of a suction and discharge CAD port, and we also introduced a new solver, ANSYS Forte, so basically exporting to new solver.
Thank you. Who can benefit from our solutions? Everyone. We believe that the whole society will benefit from more sustainable and environmentally friendly compressors. But who can use it? Screw machine engineers, R&D people, manufacturers, technical or business advisors, university teachers and researchers, and also students working on projects related to screw machines. We understand how important it is to have the best education in engineering from the first steps. We offer generous discounts to students and also academics and researchers. SCORG has user-friendly graphical user interface and allows easy pre- and post-processing with direct link to the following CFD and multi-physics solvers like Cimerix, ANSYS, Star CCM Plus, OpenFOAM, and also GT Suite. Dr. Shamrani will be the best person to explain you more about CFD modeling and our tool.
The CFD modeling consists of a solution domain, which is a representative of the problem that we are solving. And in this case, which is to do with compressors or expanders, it basically consists of different domains. For example, what you see here is a suction port, which is aligned here, and a discharge port, which is here. And in between the two domains is the main deforming chamber, which is the rotor domain. Because these are positive displacement machines, the rotor domain deforms with time, and the enveloped volume between the lobes of the rotor squeezes in order to decrease its volume. In addition to these common domains, you can also have, depending on the design of the machine, some liquid injections such as oil or liquid refrigerants. The biggest challenge in 3D CFD modeling of twin screw machines is how to generate the computational mesh for the rotors. And SCORG is a unique software tool that enables to generate the mesh by using the rotor profiles as the base, and then some parameters which can be defined to control the size of the mesh and its structure. In this particular example, what you see is a structure called as single domain conformal mesh, in which case the grid which is enveloping the rotors remains fixed in space, as you see here, and there is no interface in between the two rotors, thus ensuring highest accuracy of the flow solver. Additionally, the leakage volumes in terms of tip leakage, interlobe leakage, and the blowhole areas are accurately captured within the grid generation. On top of this, you can also have the end leakages, which can be the axial phases and can be generated through external grid generators. Once the rotor grid is generated, it is connected to the ports into the solver, and then we go into the solution. In terms of CFD solution, several solvers are available as options. SCORG grids are readily connectable to ANSYS CFX, ANSYS Fluent, Star CCM Plus, Cimerix MP, and the latest in the line is OpenFOAM solver. In this particular example, you can see the pressure solution on the surface of the rotor, and it is a compressor, so you can see during the discharge the highest pressure is seen. In the discharge port, you can see the flow velocity vectors, which represent the pulsation occurring in the port, and also the dynamic losses associated with non-uniform velocities. This example is of a twin screw expander running with R245fa and R134a fluids. Within SCORG, the geometry module allows you to calculate the chamber volume, as you can see here, and also the inlet and the exit areas, which can be used to generate theoretical ports. So in the initial design phases, when you don't have the real geometry of the expander, you can work with theoretical ports and built-in volume index can be set as per the design. In this example, we have used different equation of states such as the Peng-Robinson, Redlich-Kwong, and Sauber-Redlich-Kwong. And in addition, also the RefProf database can be coupled directly with the flow solver in order to see the accuracy of the solution. A typical grid in the cross-section of the rotor is shown here. This is the male rotor and the gate rotor. And as you can see, the nodes are connected one-to-one between the two rotors, which is an example of a single domain conformal mesh. It's quite unique to SCORG as a grid generator, and it enables a robust solution, enabling good stability of the solver and also giving a high accuracy of flow and power estimates. Here you can see the results of pressure distribution using RefProf fluid for R245fa, and this is the temperature distribution. In pressure, there is a lot of uniformity within the chamber, but you can see it is not the case with temperature. Due to leakage flow and non-uniform temperature, it can be accurately captured using the CFD model. There are some advanced examples such as oil-injected compressors, as you can see in this video. The oil is treated as a secondary phase, and the gas of compression is the primary phase, and the whole solution is solved using two-phase Euler-Euler solution. This particular example is from the ANSYS CFX solver. Here you can see some non-conventional rotors, such as variable lead type, where there is a larger lead on the suction end and a lower lead on discharge end, or a conical rotor. So these designs are not yet available in manufacturing, but they can be easily computed using SCORG grid generator. Similarly, you can have a dual lead rotor, or some external gear pump examples could be solved. Furthermore, you can explore variety of configurations such as multiple gate rotors, multiple screw machines, internally connected twin screw rotors, as you see in this example, or a different type of machines such as vane compressors and expanders, as you see here. And the latest solver which we have integrated in SCORG is the OpenFOAM solver. The advantage with OpenFOAM is that it is a open source code, and then you can directly use it with SCORG grids through the user routines which are available with the solver. Examples which are presented here are root explore and twin screw compressors. Thank you.
Thank you so much, Sham. Based on SCORG software, the SCORG Alto platform was launched in 2020. On the screen, you can see desktop of SCORG Alto. This online platform is hosted on Microsoft Azure, giving the users their own virtual computer with the latest edition of SCORG software and learning resources pre-installed. Users can execute their ideas into solutions online from anywhere in the world. That's a real game changer in the industry during the current COVID-19 situation and beyond. Let's talk about benefits from SCORG Alto. First of all, it has incredibly fast setup. You can access your cloud platform within hours. Flexible system to obtain your first license as few as 2-week lease. Centrally managed licenses. In an educational or corporate environment, multiple users can use a single virtual machine to access SCORG at the same time. It automatically upgrades to the latest version of SCORG without user intervention. You can access from any device, desktop, tablet, or smartphone. It's security assured, and there is easy backup configuration. Automatic backup provides an extra layer of security for your data. Moreover, your data is available for a short period of time after the license expires, so you can safely retrieve it. There is unlimited capacity. The cloud solution is perfect for on-demand heavy computational and simulation jobs, as there is no limit. And there is reduced risk of system failure. No need to develop a solution locally or to carry a heavy laptop around to clients. There is unprecedented opportunity. You can visit our stand and win free license, so you can explore SCORG Auto and see how beneficial it is. It will come with GT Suite solver. Our software has been used in many countries. PDM Analysis customers, partners, and distributors are based in the United States of America, United Kingdom, India, Germany, Italy, China, Japan, Korea, and more. Our hard work is rewarded by success of our clients. They esteem that our tool is friendly, quick to learn, and provides all relevant information. Many of them use SCORG to generate high-quality meshes for CFD analysis. You can reach more testimonials on our website. We offer support in the whole process of using our tools. To make things easier for you, there are trainings available. First training is a full course on grid generation, when you can learn about basics and how to generate rotor grids. Attendees can even bring their own profile files and learn how to use SCORG grid module. Second course is about thermodynamic chamber model, where you can learn about clearance management using SCORG for generating volume curve leakage areas and perform calculations at different operating conditions. We are happy to hear your needs and provide fully customized training. We believe that making scarce expertise widely available is beneficial to everybody. Last year, we were running a webinar series, which consists of various topics from latest features, fundamentals and modeling techniques, designing machines on the cloud, working with rotor profile. They're free and accessible for everyone who wants to learn more about how to use SCORG to develop optimal design and reduce the physical cost testing. On our website, you can read nearly 100 of publications about positive displacement machines, CFD, and any other topics. In most of these publications, SCORG played a crucial role. Also, we are rewarded by the community. In this and previous year, we became most innovative in compressor technology. In the past years, Professor Kovacevic and Dr. Rane won many important awards for their contribution to the fluid machinery field. As I mentioned before, SCORG was originally developed at City University of London. There is precious collaboration between City and PDM Analysis to this day. Together, we offer research and development of positive displacement machines, as well as consultation services in the field of screw machine design and development using tools like CFD. Services offered by Center are, for example, project evaluation, software development, or even complete product design. PDM Analysis and Gamma Technologies have joined forces to offer customers reliable advanced simulation capabilities for screw machines based on the complementary strength of each tool. GT Suite is the ideal tool to model screw machine thermodynamics, flow pulsations, friction, and integration with other systems. In order to build accurate chamber thermodynamic models, information about screw machine volume geometry, inlet and outlet porting, and clearance gaps must be known. This information can be calculated in SCORG. Integration inputs calculated from screw geometrics in SCORG are automatically populated in the GT Suite interface. On our website, there is a whole webinar about how these two solvers work together. You can access it anytime. Moreover, today is a terrific occasion to learn more about it. There will be a session conducted by Professor Kovacevic and John Harrison. It's arranged for live demonstration of SCORG and GT Suite and the integration with emphasis on new features, including optimization of screw machines. The conference will be followed by a short course and forum on CFG in rotary positive displacement machines. These forums are organized since 2013. This is an excellent opportunity to learn about how new technologies are made, about state-of-art in modeling positive displacement machines from the leading scientists in that field. We would like to recommend these topics: Advances in Screw Machine Technology by Professor Kovacevic, Deforming Grid and Modeling in Twin Screw Machines by Sham Rane, and also Screw Machine Integrated Models, SCORG and GT Suite, which will be presented by our partner organization, Gamma Technologies. I'd like to encourage you to visit our stand and explore more about SCORG. You can find there an article about new features, links to websites, and also you can access their branded gifts and free license. To stay in touch with us, follow our social media, register to the newsletter on our website. Thank you so much for today.